had a great fall break, and hopefully you're ready to learn. So we're going to go through our math lesson this way today. As we're going through, if it's problems that I am just talking to you about and showing, please feel free to write them on your whiteboards and kind of go through it with me. The more you pay attention through those, the better it'll be when I have you try some on your own. So there will be times throughout this presentation that the video will be paused and you will try the video, and then Mrs. Alexander will push play when it looks like the majority of you have tried, and then you'll check your work with me. So today's lesson is called Greatest Common Factor and Sum. So if you remember back to lesson 9, we created equivalent expressions by combining like terms. So lesson 10, we're still going to be creating equivalent expressions, but we're going to go to another way that we can create an equivalent expression. So if you remember, an equivalent expression, right, means an expression that's the same as the original one that they gave you. So now this says greatest common factor and sum. So if you remember back, we found the greatest common factor and the least common multiple back in number systems. So we're going to review that for a little bit today. And we know from just the last few lessons that sum, right, means addition. So, all right, let's go to our learning target. Okay, it says I can generate equivalent expressions using the distributive property, and we're going to talk about that distributive property a little bit. So, as you go throughout today's lessons, there's 2 skills that we need to understand. Okay, the first one, we need to understand or remember how to find the greatest common factor of 2 numbers. So, let's look at this first one together. You guys can write this on your whiteboard. Okay, we have 35 and 56. So if you remember when we did greatest common factor, right, we wrote the 2 numbers and then we created a ladder. And we had to think of a number that was a common factor between 35 and 56. So if I think about what can get me 35, right, what comes to mind is a 5 times 7. And I look at the 56 and 7 works. So I'm going to pull a 7 out front. Okay, and then if you remember, right, we're dividing that out. So 35 divided by 7 would give me 5. 56 divided by 7 would give me 8. When I look at my 5 and my 8, they have no other common factors other than 1. So remember, greatest common factor is what is out front. So in this case, the GCF is 7. Now, if there were multiple numbers out front, remember we would have to times them. But where there's only 1, that just becomes our greatest common factor. Okay, let's try another one. So 32 and 48. Go ahead and write this on your whiteboard. Okay, so you should have wrote 32 and 48. So again, I always like to start with a smaller one, and I try to think of what numbers get me 32. So I know because they're both even that 2 does. So I could pull out a 2, but if there's something bigger, it kind of helps me not to have to do so many levels of my ladder. So in this case, I'm going to pull out a 4. I know that 4 goes into 32 and 4 goes into 48. Now, again, there were other numbers you could have chosen. So 32 divided by 4 is 8. 48 divided by 4 is 6. Now, when I look at 8 and 6, I have to draw another ladder because 8 and 6 both have a common factor, which is 2. 8 divided by 2 is 4. 6 divided by 2 is 3. 4 and 3 have no other common factors. So this is what I was talking about last time. If you remember, we take what's out front and we multiply them. So 4 times 2 is 8. So our greatest common factor is 8. So on today's lesson, you will be finding the greatest common factor for every problem that you do. So that's something I wanted to review with you. Okay, using the distributive property. Now, this is something that's different. When we think of that word to distribute, right? If I have something to distribute to people, right, or I distribute the papers, I'm handing them out. I'm giving them to each person, right? So that's when you're thinking of distributive. Just think of what it means. It means to distribute. Okay, so we're going to see something that looks like this. Okay, and they're going to ask us to use the distributive property. So when we distribute, again, right, we're taking what's out front right here. And remember, a number out front of parentheses means to multiply. So we're actually going to distribute that 8 to everything in the parentheses. So we're going to distribute the 8 to the 12 and the 8 to the 5. When you do these, I want you to draw those lines. It'll just help your mind visually see that you're taking that 8 to both numbers. So 8 times 12 is 96, and 8 times 5 is 40. We keep the sign the same. So we created an equivalent expression right here, right? This expression and that expression, 96 plus 40, are the same thing. Now, we could take it a step further and we could say, okay, 96 plus 40. Well, 96 plus 40. 6 plus 0, 6. 9 plus 14, or 9 plus 4, 13. So now this is equivalent to this, and it's equivalent to that. Okay, so again, we're using the distributing. We're taking the 8 through and the 5 through, using the distributive property. So let's look at another one. Go ahead and write this down on your whiteboard. Okay, so I have my number out front, which is my 5, and I am distributing it, right? And again, I have to distribute it to everything in the parentheses. So 5 times 6 is 30, and I 5 times 10 is 50. So again, when you think of equivalent expressions, just think of another way to write it. So this is equivalent to this, which if I keep going, is also equivalent to that. So again, distributing the number out front. Okay, write this one on your whiteboard. All right, so this one looks a little bit different than the one before, right? This has our variables in there, but we've worked with variables throughout all of the expressions. So the process still remains the same. I have a number outside of parentheses, so I'm going to distribute it through. Now, I'm going to distribute it to the coefficients, okay? So I'm going to go 6 times 2 is 12. But I still have my x because I did 6 times 2x, right, is what I'm doing when I'm distributing. And so I have 12x. That x has to stay there. Because if we were to evaluate this, x could stand for a number, so we can't just drop it. Okay, same thing over here. Okay, 6 times 5 is 30, and I still have that x, the plus sign. So this expression is equivalent to this expression. Now, this goes back to lesson 9. Can I combine these? Yes. Same variable, same exponent. Remember, there's an imaginary little 1 right there. So 12x's plus 30x's would give me 42x. So again, this expression is equivalent to this one, which is equivalent to this one. So that would mean whatever x is. So if x was 2, I could plug a 2 here, a 2 here, a 2 here. Sorry, that 2 didn't show up. A 2 here, and a 2 right there. And if I found the answer to all of these, they would all equal the same thing because the expressions are equivalent. Okay? All right. So those two skills, greatest common factor and that distributive property, are going to help us with our assignment today. So the directions say create an equivalent expression using the greatest common factor and sum. So every expression will have the greatest common factor and a sum, which we know sum means addition. Okay, so I'm going to try a couple with you, and then again, I'll have you pause the video and try a couple. Then I'll come back and do a few more, and then have you try a few. So, okay. Now, again, you are welcome to write this down and do this with me. Remember, we learn a lot more when we're able to actually do something than just hear it and see it. So, okay, so the first thing we're going to do, we need to find, because if you remember right here, it says the greatest common factor and then the sum. So the first thing we're going to do is what comes first, which is the greatest common factor. So we're going to take these two numbers and we're going to draw our ladder because that's how we find the greatest common factor. And I have to think of a number that is a factor of both 15 and 40. So if I look at this, 15 and 40, I know 15 is 3 times 5. 3 doesn't work for a 40, but a 5 sure does. So I'm going to pull out a 5. 15 divided by 5 is 3. 40 divided by 5 is 8. Okay, again, I look at my 3 and my 8. Anything in common? Nope. The only common factor is 1. So here's now how I create my equivalent expression. So it said I want to find the GCF, which I just did. So I bring that out. Okay. Then these are going to look like those distributive properties. I'm going to put my parentheses. And I'm going to take what's left here. So I had a 3 left. Is a plus sign. Because remember, it's a sum, a greatest common factor and a sum. And my other number is 8. So what we just did here, we created an equivalent expression. So this right here, right, 15 plus 40, if we did that, right, is 55, is the same as 5 parentheses 3 plus 8. And again, the nice thing about every one of these problems is you can check them. Okay, I can distribute this. 5 times 3 is 15 plus 5 times 8 is 40. When I do that, it should get me back to the original, which again is 55. So they're both equivalent. Okay. Now you probably say, well, what is my answer? Okay. Well, they wanted you to create an equivalent expression using the greatest common factor and the sum. So your answer is actually this part right here, because this is the part that has your greatest common factor and your sum. Okay. So again, if we can find the greatest common factor, the sum part's easy because it's what's left right there. Okay, let's look at another one. Okay, again, you can write this down, but we're going to follow the same steps as last time. So the very first thing we're going to do is create our ladder because it's GCF and sum. So we have to find the greatest common factor. Ooh, 33, 44, what comes to mind? Hopefully 11 comes to mind that you can pull out 11. So 33 divided by 11 is 3. 44 divided by 11 is 4. Okay, 3 and 4 have no other common factors. So now I use this information to write my answer. So the first thing is my greatest common factor is 11. And then I put my parentheses to get my sum, right? And you can even bring down that plus sign right there if that helps. So I have a 3 plus 4. Okay, so I just created an equivalent expression, right? This is equivalent to this, and I check it. Okay, 11 times 3 is 33. 11 times 4 is 44. That got me back to my original. So my answer, right, is this right here. 11 parentheses 3 plus 4 parentheses. Okay, so when you think of equivalent expressions, right, we're not getting to a final answer. We're just writing our original problem right here in a new way, okay, because we want it to be the same, equivalent, but just writing it in a new way using the grade. Okay, so hopefully you've tried this problem. I'm going to go through and do it, and you compare your work. So when I have 50 and 70, hopefully the common factor you thought of was 10. That's the easiest. So 50 divided by 10 is 5. 70 divided by 10 is 7. Now, you could have thought of 5. You could have done a 2. In the end, you're still going to get the same greatest common factor. So our greatest common factor is 10. And our sum, right, is that 5 plus 7. So this is our answer, but we can always check them. So when we distribute, 10 times 5 is 50. 10 times 7 is 70. So yep, it's equivalent. So my answer right here of 10 parentheses 5 plus 7 is correct. Okay, moving to the next one. Again, go ahead and pause the video. You create equivalent expression using the greatest common factor and sum, and press play when everybody's ready. Okay, let's go through this. So we need to find the greatest common factor. Ooh, I know 8. I think of 8 and 10. 8 also works for a 64, so I'm going to pull an 8 out front. 64 divided by 8 is 8. 80 divided by 8 is 10. Now, I cannot stop here because 8 and 10 also have a common factor, which is 2. 8 divided by 2 is 5. 10 divided by 2, or sorry, I was thinking of the next one. 8 divided by 2 is 4. 10 divided by 2 is 5. Okay, I find the greatest common factor. Remember, whatever's out front, I multiply it. So we should have had 16. And then I take what's left at the bottom of my letter, 4 and 5, and it's a sum, right? So I put my plus sign. So this is my answer, and again, I check it. So I distribute, use that distributive property. 16 times 4. Well, I better check that. It's not one I maybe know off the top of my head. 6 times 4 is 24. 4, 5, 6. Okay, so that got me 64. 16 times 5. 6 times 5 is 30. 5, 6, 7, 8. 80. So if it matches my original, and I found the greatest common factor, that's my equivalent expression. Okay, so this one I'm going to do with you because if you notice, now we don't just have numbers. It's not a numerical expression. Now we have an algebraic expression. Okay, the process doesn't change. We just have to now be concerned about the variables as well. So I like to take care of the variables first. So remember, what do we pull out front here? We pull out common factors, right? So we're going to pull out common variables. So this one has an X and this one has an X. So I get to pull it out front because both of them have it. Okay, so if I take an X out, right, I'm still just left with my 30 plus 45 because X got pulled out front. Now I have 30 plus 45. A common factor is 5. 30 divided by 5 is 6. 45 divided by 5 is 9. Oh, I still have a common factor. I could have done something bigger than the 5. I didn't think of that. 6 and 9, I know they have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now I look at 2 and 3. Nothing else in common. I'm going to bring down that plus sign. So remember, I write the greatest common factor. Okay, so 5 times 3 is 15, but I can't forget about this guy that I pulled out. I have a 15x, right? And then what's left in parentheses? Right here, 2 plus 3. So again, this is my answer. Okay, that's my equivalent expression, but I always like to check it. So if I distribute the 15x times 2, well, 15 times 2 is 30, and I took that x through as well, right? So this is a whole term that's going through. Okay, plus, so the 15x is going to 3. 15 times 3 is 45, and that x, right? This guy comes through too. Got me back to my original. So, kind of messy, but my answer, right? The greatest common factor is 15x, and the sum is 2 plus 3. So, the variables, okay, the numbers, the process doesn't change. The variables I just have to think about if they both have the variable in common, because remember we pull common things out here, then we can pull it out. Okay, let's look at another one. Okay, and feel free to write this on your whiteboard and do it with me. So I make my ladder. So I look at my variables first. I have a v here, but I have no variables here. So there's no variables in common, so I can't pull any variables out front. So now I go to the numbers. Ooh, I know money, 25 and 75. I actually know that 25 can go right there. So 25 divided by 25 is 1, but I haven't used this v, so it stays with it. Okay, and bring down my plus. 75 divided by 25. Well, how many quarters get me 75? Which should be 3. Nothing in common in a 1 and a 3. So my greatest common factor, remember I write that first, and then I write my sum. Now I can write 1v or I can just write v, because if I just write v, remember we know there's that imaginary 1 there, plus 3. Okay, so that's my answer. Now I check it. 25 times v, 25v plus 25 times 3, 75. Got me back to my original, so this is correct. So if you look on this one, okay, right, I couldn't pull out those v's because this didn't have a v. Now, if that did have a v, then I should have pulled those out front. But because it was only right here, they don't have it in common, so I can't pull it out. Okay, let's look at this one. So I worry about my variables first. So if you remember, I want to explain something. So if, let's say we had two, oops, my pen. Okay, let's say we had 2 squared, right? And we wrote that in expanded form as 2 times 2, right? Or if it was 4 to the third, we wrote it as 4 times 4 times 4. So variables are no different. If I have, right, if I have x squared, that means x times x. Or if I have x cubed, that's x times x times x. Remember, an exponent tells me how many times my base is used. So my exponent tells me how many times I multiply that base. Okay, so let me erase this stuff real quickly. Sometimes it doesn't erase super awesome. I want you to keep that in mind because we are going to use that expanded form to help us up here. So again, I want to worry about my variables first. So what is m to the second power m squared really saying? It's really saying 44 times m plus 88m, right? I just took that m squared and wrote it m times m. So now I'm going to draw my ladder. Now, how many m's are in common? Well, this one has one here, and this one has one here. So I can only pull one m out front because that's all that's in common. They don't both have 2 m's, so I can only pull out what's common. So I took these out. So what am I left with? 44. And I still have this m because I only got to pull out one, plus 88. Okay, so my variables, I can't, nothing else in common in the variables. So now I work about my numbers. Okay, I'm going to plot an 11. 44 divided by 11 is 4, and I still have that m. 88 divided by 11 is 8. Now, a 4 and an 8, they got something in common. They have a 4. Okay, 4 divided by 4 is 1, and I still have my m. 8 divided by 4 is 2. Nothing else in common. So, greatest common factor is what's out front. 11 times 4 is 44, and I have a what letter? I have an m, parentheses, 1m or just m, plus 2 is my sum. So there's my equivalent expression. Now I'm going to check it again. Okay, 44m, right? Remember, this is a whole term. 44m times m. Well, m times m is m squared. So I have 44m. Next, we got two more I want you to try. Okay, pause the video and try this one. Press play when you're ready. Okay, I'm going to rewrite it. This is 12b times b times b plus 32. Any variables in common? Nope, because 32 doesn't even have any variables, so I can't pull any out front. So now I go to my numbers, 12 and 32. What can I pull out of it? 12, 32, I'm going to go with a 4. 12 divided by 4 was 3. Now, I can keep writing a b times b times b, but I'm going to take it back to b cubed because I didn't pull any out. Plus 32 divided by 4 is 8. I look at my 3 and my 8, nothing else in common. So in this case, what's my greatest common factor? 4. What's left in parentheses? 3b cubed. Sorry, I'm writing on a computer screen. Doesn't work always. Plus 8. So there's my answer. Now I check it. 4 times 3 is 12. B cubed, because the b cubed is there. 4 times 8 is 32. Got me to my original. Okay, last one. And then you'll do some group work. So try or pause this one and try it. And then press play when you're ready to go over it. Okay, here we go. So 60h times h plus 90b. We look at those variables. Nothing in common. So we just leave them. Now we go to our numbers. Let's pull out a 10. 60 divided by 10 is 6. Now I have those two h's. I'm going to take it back to that h squared. Plus 90 divided by 10 is 9b. Ooh, I need another ladder because I know 6 and 9 have something in common, which is 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now I can't forget that h squared comes down and that b comes down. 2 and 3 have nothing else in common. So greatest common factor, 10 times 3 is 30 out front. What's left? 2h squared plus 3b. Okay, that's our answer. Now let's check it, right? Check every single one of them. Then you know you haven't made a mistake. So 30 times 2 is 60 h squared, because the h squared's in there. 3 times 3 is 90, and I got a 0, so 30 times 3 is 90, and I have that b. Checked it. Okay, hopefully, right, if you have any questions, maybe you guys can have a class discussion, or Mrs. Alexander can answer a few things for you, but hopefully, right, if you just follow those steps, take care of your variables, and then greatest common factor, you should do great. If you're still a little confused, we will review this again a little bit tomorrow. So you are going to try. Okay, remember, do your variables first, like we did right here with the M, and then do your numbers. Okay, so go ahead and write this on your whiteboard, pause the video, try it, and then again, I'm going to come back with you and go over it. Okay, so let's see what you got. Oh, actually, before I even draw my ladder, I want to write out my variables. So this is 12B times B times B, right? Because there's 3 B's, plus 32B times B. Now I draw my ladder. So how many B's in common? Well, the 32 only has 2 B's, so I can take these two and I can take these two. Now, when I put them out front, I can't just write a B because I took 2 of them, so I have to put B squared. Okay, now I worry about my numbers. So 12 and 32. Ooh. Well, let's rewrite. Sorry, that makes this easier. 12 is left and 1 B is left, plus 32. But I don't have any B's left because I took 2 of them out. Now draw my ladder. Okay, my 4 comes out. 12 divided by 4 is 3, but I still got that B. 32 divided by 4 is 8. So if I look at my 3 and my 8, nothing else in common. So greatest common factor is out here. 4B squared, parentheses, what's left underneath? 3B plus 8. Okay, we check it using the distributive property. So 4 times 3 is 12. B squared, and we have another B, so that's B cubed, plus 4 times 8 is 32. And this B squared comes through back to my original. So 4B squared, parentheses, 3B plus 8 is my answer. Okay, pause the video and try this one. When most of you are done, we'll press play and you can check it. Okay, let's go ahead and check. So let's write it out. 24H cubed, right, is going to mean H times H times H plus 28. Ooh, H cubed again. H times H times H. Draw my ladder. So how many H's do they have in common? 1, 2, 3. 1, 2, 3. So I pull H cubed because all of them are in common. They both have H cubes. Okay, what's left? My 24 plus 28. And then I look what comes out of a 24 and a 28. 4 does. 24 divided by 4 is 6. 28 divided by 4 is 7. Nothing else in common. So greatest common factor is 4H cubed. What's left? 6 plus 7. So there's my answer. Now let's check it with the distributive property. 4 times 6 is 24, and I have H cubed going through, plus 4 times 7 is 28, and I have that